exponential functions, right? Um, so far, all of our functions have looked like constant to the power of x, right? 2 to the x, 3 to the x, and so on. Today, we're going to get a little bit more specific, a little bit more specialized, okay? And we're going to talk about what we call the natural base, right? So far, right, we have had like 2 to the x, 3 to the x. Today, we're going to make that into the natural base. I've been, saying over and over again how exponential functions fit really well into many real life situations. Um, Actually, most of the real life situations which can be modeled by exponential functions have not 2 or 3 as the base, but this natural base as their base. Okay. The natural base is an E. It's a symbol E. All right. Now, a little bit of background about where it comes from. This term, 1 plus 1 over x to the power of x, this term is something that shows up very, very frequently in a lot of math calculations. It's just so many formulas and equations sort of reduced to this in the end. And then, so what we normally need to do with this is we graph that in the blue box. And when you graph that function, it looks like this, where it increases very slowly and then it levels off. And it just so happens that the point where it levels off is always the same number, 2.71828, blah, blah, blah. It's a non-ending number. And because this is something that occurs so frequently in so many applications, it's given its own symbol, which is an E. So just like 3.14159, that number, right? It happens so often that we gave it a special name, pi. This is another one, E. Okay, so why E? Well, it's called E and not another letter because the mathematician who discovered this was this guy, right? Name starts with an E. It's pronounced Euler, not Euler. Very common mistake. Everybody mispronounces this and calls the poor guy Euler. It's Euler, Leonard Euler. And his name starts with an E, so it's named after him. Okay? All right. Fun fact about Euler. He is credited to discovering so many different theorems, facts, constants, and so on, that there are a whole bunch of things named after him. In fact, at a certain point, the mathematical community, they stopped naming things after him because everything was becoming like Euler's theorem, Euler's formula, Euler's constant, Euler's method. And so they stopped naming things after him and they started naming it after the second person who discovered the same thing after him. So like the second runner up, just so like other people could get a chance, right? That's Euler. Okay, so what you need to know about E is that it's just a regular old number and its approximation is 2.718. Okay, now, so, it's just like, if, we have like the number 1, 2, and then E, and then 3, right? Like it's just an old number, just like that. Okay, so let's do one. So right now, we're going to graph our very first exponential function with a base of E, right? So if I see e to the x, that's just like 2 to the x, 2.5 to the x, or 2.7 to the x, or e to the x. Because it's just like any of the other ones, the asymptote is still the same, okay? The y-intercept is the same process. Y equals e to the 0. Anything to the 0 is 1. pencil to the 0, table to the 0, all 1. So it's 0, 1. Okay. And let's do some of these here. So we have e to the minus 1. All right. So for these, we're not going to do them by hand. You're going to plug every single one of them into your calculator. So let's go ahead and do that. Okay. E is this button here, okay, to the far left of the 1. And you see how it's a bold E and it gives you like the little exponent field. So here we're going to put in -1, and there we go. All right, now, how much do we round? You're doing this table to graph. So let me ask you, can you graph by hand the difference between 0.3 and 0.36 or 0.4? No. So 0.4 is good enough. Okay. E to the 0 we just said was 1. E to the 1, right? Same thing. We're just going to plug it in. E to the 1 to prove to you that it's the same as what I just said, right? 2.718. And then we have E squared, which is 7.4. Okay, make sure you use that E button and not like the letter E from the keyboard on the bottom, okay? All right, domain. This is an exponential functions. So domain is all real numbers, just like before, right? So let's see if we can predict the range. Remember how the range was always y is less than or equal to whatever the asymptote is? And remember how yesterday I said you look at the coefficient of the function. And if it's positive, it's greater than 0. And if it's negative, it's less than the asymptote. Let's see if our prediction was right. Let's graph this guy. At -1, y is 0.4. At 0, y is 1. At 1, y is 2.7. And then at 2, it's 7.4. We graph and look, right? It's almost indistinguishable from some of the other ones we were graphing because it's exactly similar. All right, so let's do another one. For this next one, we have e to the 2x plus 3. So somebody, can you shout out to me what the asymptote is going to be?
3.
Y equals 3. And the y-intercept, right? E to the 2 times 0 plus 3. E to the 2 times 0, that's e to the 0 plus 3. 1 plus 3, that's 4. Okay. Right, so here we're going to do e to the 2 times -1 plus 3. That's actually e to the -2 plus 3, right? So when we go on the calculator here, I have e. Now in that exponent space, it's up to you. You can either do 2 times -1 like this, or you can just do -2. Okay, but what we want is e to the -2 plus 3, right? We're going to put in the plus 3, exit out of the exponent by pressing the right arrow button and do plus 3. So make sure the 3 doesn't get jumbled up with the exponent. That's a very common mistake I see students make. And then, you know, your answer is obviously like totally off when you do that. So that's 3.1.
Do you always want us to include the decimals in our answer?
At least one, yeah, because we do want it to be like different from, like if it's 3.5, that's different from 3. So this one we had just said it was 4. Here, e to the 2 times 1, that's e squared plus 3, right? And then here I have e to the 4 plus 3, right? So e squared we had said was 7.4, so that's 10.4. And what's e to the 4 plus 3? Who can tell me? 3?
I got 57.6.
Yes. Okay. So now the domain is all real numbers. And what do you guys think the range is? Is it greater than, less than, what? Greater than what?
Greater than.
How much? 4. Why is greater than 4? Because that's what my asymptote is. All right, so asymptote is y equals
Can you
4.
Isn't it 3? I think.
Oh, I'm so sorry. It's 3. I'm so sorry. I looked at the y-intercept. Okay, so 3. Okay, so -1, we're at 3.1, then 4, then 10.4. Okay, so now watch this for a minute. So I had said I want at least 3 points when you graph, right? So when you're doing this on the homework and you come across this, this is 10.4. So make sure you don't have to graph the 57.6 because it's way too large of a number, but you at least need the 10.4. That means you would have to calibrate your y-axis so that it goes up to at least 11, so you can put in the 10.4, okay? For this one, because we're just practicing, I'm just gonna put it here, but we never put a point outside of the grid, okay? All right. Let's do one more. This time we have negative e to the 2x, right? So, all right, so yell it out. What's the asymptote here?
0.
Y equals 0. Okay, intercept. Y equals negative e to the 2 times 0. That's negative e to the 0. That's -1. All right, so here I'm going to have negative e to the 2 times -1, negative e to the -2, negative e to the 0, I just did it, negative e to the 2, negative e to the 4. Go ahead and put in those points, please. And then I'm going to call on people to tell me what they are. So go ahead and fill in those boxes. Okay, so those are our values, right? Again, the 54 is just way too small or large, so we don't need to do that. But I've got the asymptote here. At -1, it's -0.1. At 0, we're -1, and then -7.4. Okay. The domain is all real numbers. And the range, right, is y is less than 0. And we could have predicted that it was going to be less than because of that negative all the way in the front of the equation. Okay? All right. Last but not least, go ahead and do this one. I'm gonna give you guys about 2 minutes to just do this left-hand side. Don't graph just yet, okay? Just do the left-hand side. All right, 2 minutes. I'll pause the recording for 2 minutes and we can come back.
-4.
Right, y equals -4. And anybody have the y-intercept?
0 and -5.
0 and -5. Okay, so here, right? What's that first value? What's the y value for the first one? Jacob, do you have that one?
Yeah, I got -4.5.
Yes. Yeah, I think I have -4.4, but it's the same. So here for 0, we said it was -5. And here, -e⁻1 -4. Who's got this one for me? Ruby?
-6.7.
Yes. And then -e² -4. That's going to be -11.4. Okay, so for this one, right, domain is all reals. Okay. What about the range? What do you guys think about the range?
Y is less than -4.
Yes. Okay, so for this one to graph, right? I do want to get a lot of these points. So look, I have an 11.4 and that's a very reasonable value to graph. So you know what I'm going to do is I'm going to switch my points here. I'm going to go up by 2s, -2, -4. So this is an 8, 12, -16, -20. Okay. Take ownership of your graphs. Make sure I can see everything, right? And make sure, like, you know, it's labeled correctly and right. Okay. So the y-intercept, the asymptote is -4. And then I have -4.4 for -1. Then -5. Then -6.7. And then -11.4. And that is what that looks like. Okay. And that takes care of the lesson for today, right?